Alrighty, in Unit 6, we're talking about exponents. So in this first section, we're going to talk about a bunch of different rules that apply with exponents. So starting off very basic, if we're talking about an exponent, that is that tiny little number that goes at the top right of either a letter or a number. And the big number or letter is called our base. So if we have something like 3 to the second power, that base is happening how many ever times the exponent tells us. So it was that base happening 2 times in multiplication. So that 3 times itself 2 times, and we can simplify that because we know 3 times 3 equals 9. So looking at some examples, if I wanted to know what 5 squared is, that means that base of 5 is multiplied times itself 2 times. And I know this seems very simplistic, but that's the point. We're starting off super simple. So that 5 times itself 2 times, and that could equal 25. Okay, again, we have a 4 to the third power, so that means that's a 4 times itself 3 times. Now, if you've never plugged this into your calculator before, you're going to hit a 4. And then if you see right underneath the button clear, there's a little arrow up button. I like to call it a caret. If you hit that, it will take you up to the exponent, and you can put a 3 in the exponent. So when you type it into your calculator, you get a positive 64. Okay, again, if I want to do 1/2 to the 5th power, that is 1/2 times itself 5 times. And if you want to type this into your calculator, you would put in parentheses a 1 divided by 2, and then use that caret button again and put the 5 in the exponent. So if you do that in your calculator, you're going to get a decimal. Now we don't want a decimal, so we're going to hit math, enter, enter, and that gives us 1/32. All right, last example, I want to do 3/5 to the third power. So I'm going to do 3/5 3 times. And if you want to type this into your calculator, you can do parentheses 3 divided by 5 to the third power using that caret button. Again, we get a decimal, so we're going to hit math, enter, enter, and it gives us 27/125. Now, a cool little trick with these fractions is if you notice, 1 to the 5th power is 1. 2 to the 5th power is 32. So it gives you the same thing as if you were to do it with your fraction to that power. Each, the top and the bottom, are the same thing to that exponent. Same thing with this one. If you did 3 to the third power, it would give you 27. And 5 to the third power would give you 125. Either way gives you the exact same thing. Okay, looking at some more examples, we want to know what is x to the 4th times an x squared times an x to the 5th. Now, I'm going to write this completely out, and then we're going to talk about what's called the product rule. So kind of a pattern that we see that's happening within that rule of these exponents. So the first time I'm going to write it out, I have an x to the 4th. So I had an x times itself 4 times. Then I had an x squared. So I had times 2 more x's times an x to the 5th. So times 5 more x's. So if I look, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 x's, which if I have 11 x's times each other, that means I have the same thing as x to the 11th power. Now, if you notice, we could have done a rule with this, which means that 4 plus 2 plus 5, all of those exponents added together, could have also given us 11. So if I would have done x to the exponent of 4 plus 2 plus 5, it would also give me x to the 11th. So our product rule is whenever we're multiplying our bases, we can add our exponents. Okay, let's try this again. I had 3 to the 6th power, and I'm going to write it all out. So I had 3 times itself 6 times. And then I had another 3 to the 3rd power, so 3 more 3s. And times another 3. If you want, you know that's an 3 to the 1st power because there was no exponent. So if I look, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 3s. So that's the same thing as 3 to the 10th. Now, in this situation, I can type in 3 to the 10th power into my calculator, which if I do that, it gives me 59,049. Either one of these is the same thing, but whenever you're able to evaluate it, I would do so in your calculator. Okay, the same rule applies with that product rule. If I take my exponents, the 6, the 3, and the exponent of 1 that we knew was there but wasn't really there, we add them together. 6 plus 3 plus 1 is also 10, and if, again, I plug it into my calculator, I get the exact same thing when I evaluate it. Okay, let's look at another example. Now we're adding x's, y's, and numbers all in this situation. So with the first one, I have a 4, and how many 4s do I have? Well, this 4 has an exponent of 1. So I'm going to put a 1, 4. This x also has an exponent of 1. So I'm going to put 1x. And the y had 2 y's because it was y squared. Okay, then I have times 1, 5, 3 x's, and 4 y's. Okay, so I look and I have a bunch of things happening. With my numbers, I have a 4 and a 5. Now, all of these things are being multiplied. So I'm going to multiply those two numbers. 4 times 5 is a 20. Then I look at my x's. I have an x here, 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 and here. So I had 4 x's, which means I could write that as x to the 4th power. Then with the y's, I have 1, 2, 3, 4, 5, 6. So that could be written as y to the 6th power. Now again, our rule could apply here. With our big numbers, those bases, I'm still going to just multiply them. So that 4 times 5 still gives me 20. That x to the 1st plus 3 more x's, I can add those exponents, giving me x to the 4th. And the y's had a power of 2 and a power of 4. If I add those together, it gives me y to the 6th. So I still get my same answer of 20x to the 4th, y to the 6th. So our rule with this, whenever we were multiplying, so when multiplying bases, or let's say same bases, we added the exponents. So this is a rule that you can apply no matter what. Now, if you're starting to get confused with the rule, you can always go back to writing out all of those letters and seeing what happens. Alrighty, so let's look at what happens when we divide. So if I have on top an x to the 6th, that means I have 6 x's on top of my fraction. And on bottom, there was x to the 4th, which means there's 4 x's on bottom. So if I simplify this, whenever I have the same thing on top and bottom of my fraction, those things can cancel because something divided by itself equals 1. So I'm going to cancel anything that pairs up. So everything that paired up on top and bottom was canceled, leaving me with x times x on top, which I can write as x squared. And there was nothing left on the bottom of my fraction, which we could represent as divided by 1, which in this situation, I really don't need to show that there was anything on bottom, so I'm just going to leave it as x squared. Now, you could also use a rule with this. If you notice, we had a 6 and a 4, and it became 2. So we could have taken our x to the 6th and subtracted 4, giving us x squared. So whenever you're dividing your x or your variables that are the same or numbers that are the same, with the exponents, you're going to subtract those exponents. Okay, same thing on this one. Let's write it all out. On top, we had x to the 5th. And on bottom, this was an h to the 1st, so I'm only going to write 1h, which means that these can cancel out. Nothing else cancels out, so we're left with 1, 2, 3, 4 h's on top, or h to the 4th, which again, you can use your rule. We had a 5, and we divided, so I could subtract whatever was on the bottom, which was 1, leaving me with h to the 4th. Either way is fine. Alrighty, with this example, we have numbers and letters. So on top, we had 6 to the 5th power. So that's 6 5 times. And 4, or m to the 4th, which is 4 m's. On bottom, we had 6 to the 3rd, so that's 6 3 times. And m to the 3rd, which is m 3 times. So we're going to cancel any 6's that are on top and bottom, and any m's that are also on top and bottom. So once I cancel, I see that I'm left with 2 6's on top, which is 6 squared. And also on top, we are left with 1m, which is just m. Now we also know that 6 squared we can do on our calculator, which would give us 36, and that m is just going to stay m. We could have also used that rule we talked about by subtracting our exponents. So the 6's, we had a 5, and on bottom we had a 3, so 5 minus 3 would give us 6 squared, which again we know 6 squared equals a 36. And with the m's, we had a 4 on top and a 3 on bottom, so 4 minus 3 would give us m to the 1st, which we know is just m. So again, we would get a 36m. So our rule is when dividing same bases, we subtract exponents. Alrighty, in this next one, we are going to talk about negative exponents. So negative exponents are kind of the no-no in the world of math. You cannot ever have a negative exponent in your solution. So in order to fix that issue, we're going to have to switch the location of where that negative exponent is at. So on this first one, we have d to the negative 7. Now, we know that anything that is not a fraction is really divided by 1. And that's important because whenever we have a negative exponent within anything, we're going to have to flip it to either, if it's on the top of a fraction, it needs to go to the bottom. If it's on the bottom, it needs to go to the top. So in this situation, we have it on the top of our fraction. So it's going to flip to the bottom of our fraction. So it's going to become 1 over D, and that 7 is now going to become positive. And in this situation, there's really nothing else we can do. So this is our final answer. It just fixed that negative exponent. That's the no-no in the math land. Okay, on this next one, we have a C with a negative exponent on the bottom. So it needs to be flipped to the top. So it's going to flip where that C to the positive 1 is on top, and 1 was left on bottom. Now, in this one, we don't really need to say divided by 1, and we don't really need to say to the exponent of positive 1. So we could just say C, we know it's to the positive 1 exponent, and we know that it's divided by 1. We don't have to write it. In A, we had to say 1 on top because it made it a fraction. Alrighty, let's look at this last example. So we have a 3x to the negative 2 and divided by a 2x to the positive 5. So we need to fix the thing with the negative exponent. Now, a lot of people think, oh, I need to move the 3x to the negative 2. But that 3 has an exponent of a positive 1. It does not have a negative exponent. So the thing that I need to move is this x to the negative 2. It needs to go down to the bottom of our fraction. That 3 is going to stay on top. The 2 stays on bottom. The x to the 5th stays on bottom. And that x that was on top is going to go down to the bottom. And it's going to become a positive 2. Now, if I were to write this all out, I have 5 x's, 3, 4, 5, times 2 more x's, which means I have 1, 2, 3, 4, 5, 6, 7 x's on bottom. So that could be written as x to the 7th. Alrighty, let's look at this next example. All of these are to the 0 power. Now, I want you to try something out before we do these examples. Type in your calculator, what is 3 to the 0 power? It gives you a positive 1. What is 527 to the 0 power? It also gives you 1. If you were to type any number to the 0 power into your calculator, I guarantee that you are going to get a positive 1. Now, that's a rule. So, on this first one, if I have x to the 0 power, it's going to equal 1. If I have 105 to the 0 power, I type that into my calculator, I also get positive 1. If I try this one, that whole 5x squared is to the 0 power, which still means that it equals 1. So that is our rule. Anything to the 0, that's really important, power, or exponent you could write, equals 1. Okay, so let's try some examples for this next one where we have an exponent on the outside of a parentheses. Okay, I'm actually going to start with B. Let's look at B first. Okay, so B, we have a to the 7th times an x, and it's happening 2 times. So that a times itself 7 times, and yes, I'm going to write this all out. 1, 2, 3, 4, 5, 6, 7 times an x. And that set of parentheses was squared, which means it's timesing itself 2 times. 5, 6, 7 times another x. Now, if we count this all up, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 a's, which we can write as a to the 14th power. Then we have an x and an x, which we could write as x squared. Okay, let's try this next one. So we have a set of parentheses that is 5b to the 4th, c to the negative 1. Now, first off, I see that negative exponent is a no-no. So I'm going to make this divided by 1. And this c to the negative 1 is going to need to go down to the bottom of our fraction. So that means it's a 5b to the 4th divided by a c, and now it's to the positive 1. And that whole set of parentheses is still to the 3rd power. So I have a 5 with 4 b's divided by a c happening 3 times. So let's write that all out. I know it seems like it's a lot to write, but I know you can do it. Okay, so with my 5's, I have all of these things being multiplied, which means it's a 5 times 5 times 5, or 5 to the 3rd power, which equals 125. Then I had 4 b's plus 4 more b's plus 4 more b's, which is going to give me b to the 12th. On the bottom of our fraction, we had 3 c's, which we can write as c to the 3rd power. There's nothing we can cancel, nothing we can simplify, so we are done with this example. Now, some of you might start to see a pattern that's happening within this. So let's talk about that. If you notice, I said 5 to the 3rd because it was 5 times 5 times 5. Now, originally in our starting off problem, that was a 5 to the 1st. So if I took that exponent that we had on the outside of our parentheses and multiplied it times that exponent of 1, that would give me a 5 to the 3rd, which we did, 5 times 5 times 5. Then, let's try that again. If I take it times the 4, that would have been b to the 12th. Now, our c moved down below, so we had a c on the bottom with an exponent of 1. And if I do 1 times 3, I have an exponent of 3 on the bottom of that c, which I can still calculate out. 5 times to the 3rd power is 125. Let's try that rule on the next one. We had an a to the 7th and an x to the 1st. So if I take that 2 and multiply it, 2 times 7 would be a to the 14th. And 2 times 1 would be x to the 2nd, which we did get in our original when we wrote out all of those letters. Alrighty, let's look at this same one, and we're going to write it all out, and we're going to apply that rule to see if it works both ways again. Okay, the first thing I notice is that we have a negative exponent. So negative exponents I'm going to deal with first. So that m to the negative 2 has a negative exponent. Remember that 7 has an exponent of 1. So he is going to stay exactly where he's at. So that m is going to move upstairs, giving us a 2k to the 3rd, and now an m to the positive 2, and that 7 is going to stay on bottom. And that whole thing is squared, so times itself 2 times. So let's write this all out. We have a 2 with 3 k's and 2 m's divided by 7, and that set of parentheses is happening 2 times because it is squared. And it's still divided by 7. Okay, so if I look, I have a 2 times 2 on top, which is going to give me a 4. Then I have 3k's plus 3 more k's, which is k to the 6th. And 1, 2, 3, 4 m's. On bottom, we have a 7 times a 7, which is going to give us 49. Now, let's see if our rule worked. I'm going to use this part of my problem because I already fixed that negative exponent. So if I use my rule, we said that we multiply that exponent on the outside times all the exponents on the inside. So let's put those exponents of 1 in there that don't have exponents. So 2 times this 1 would give me 2 to the 2nd power. 2 times this 3 would give me k to the 6th power. 2 times this 2 would give me m squared. And 2 times the exponent on the bottom would give me 7 squared. Now, I see that I can evaluate 2 squared is 4, and 7 squared is 49. So I still get this same answer. Either way you find the answer is perfectly fine. Okay, last example, we're going to try one last one before we write our rule. And I notice right off the bat that we have a negative exponent. This 3 has a positive 1, but this h has a negative 4. So I'm going to make our problem into an exponent, and that h is going to go down below. So that's going to give us a 3 to a positive 1, h to a positive 6, all divided by h to now a positive 4 to the 2nd power. So this set of parentheses is going to multiply times itself 2 times. So we have 6 f's, 1, 2, 3, 4, 5, 6 f's, and 4 h's. And that set of parentheses is happening 2 times. Okay, so on top we had a 3 times a 3, which would give us 9. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 F's on top. And 1, 2, 3, 4, 5, 6, 7, 8 H's on bottom. So again, let's see if our rule worked. We said that we take the outside exponent times all of the exponents inside. So that 1 times 2 would give us 3 squared. 2 times 6 would give us f to the 12th. And 2 times 4 would give us h to the 8th. And we know that 3 squared is 9, so we still get the same solution. Okay, so this is the rule of power to a power. So we could say that you take the exponent on the outside of the parentheses and multiply it by all, that's really important, all exponents inside the parentheses. Okay, let's also look at this chart right here. This chart has to do with switching our radicals, which we've talked about in the past, to exponents. So here's what you're going to do. This is kind of a rule for it, but let's look at the first one. And I like to always add, whenever it doesn't have parentheses, it really has parentheses with a 1 on the outside, because anything that doesn't have an exponent has an exponent of 1. So this little radical, whatever number that is the same thing. We're going to move it over, and that 32 can be to the 1 over 5, and those mean the exact same thing. So I like to type this into my calculator in the exponent form. You can type either one into your calculator, and if you need help with that, I'd be happy to help you. But let's type in 32 to the exponent of 1 divided by 5. And if you do that, you get a positive 2. Okay, let's practice that same rule again, and let's go the opposite direction. So this time, the bottom of our fraction is going to move, and it's going to become our radical. So it's going to become the 4th root of that 625, and that exponent of 1 is still going to be on the outside. Now, if you evaluate this in your calculator, I like to type in the exponent 625 to the exponent of 1 divided by 4, and you get a positive 5. Okay, let's try the next one. We're always moving the bottom of our fraction over to become the radical. So this would be a cube root of 64, and that exponent of 4 is still going to be on the outside. Okay, so if I type in my exponent form, 64 to the power of 4 divided by 3, I get 256. All right, now we're going from radical to exponent. So that radical is going to move back over to become the fraction. And we had a negative 8. Now this is really important. Whenever you have a negative, you're going to put it in parentheses to really emphasize that that negative is attached to the 8 or whatever number you're talking about. Like the one below, it has a negative 64 in parentheses. Okay, so that 3 moved back over, and so it's going to become 2 divided by 3. That radical always goes on the bottom of our exponent. Okay, so let's type this in exactly how it looks. Parentheses negative 8 to the power of 2 divided by 3. And you should get a positive 4. Now, if you would have typed this in without the parentheses, you would have gotten a negative 4. That's why that set of parentheses is so important. Okay, let's try this next one. We are going to move that bottom of our fraction over to become the radical. So it's a cube root of that negative 64. And that whole thing is still to the 2nd power. So if I type this into my calculator, I'm going to use the exponent form, so parentheses of negative 64 to the exponent of 2 over 3 is going to give me a positive 16. Okay, last one. This one's a little tricky because there's no number right here for our radical. Now, if you think back to if we were solving an equation, whenever we had an x squared, we would undo it with a square root. So if you think about it, we're undoing this exponent of 2 with a square root, which means something times itself, so 2 times. So really, we don't write it, but that has a tiny 2 on the radical. So I'm going to put that over here on this square root of 9. So the number 2 is what was hiding, and that's what's going to move over to become our exponent. So that 9 to the exponent of 5 divided by 2. Okay, so if I type that into my calculator, 9 to the power of 5 over 2 is going to give me 243. Okay, let's practice some more, and I'm going to do this by writing all of these out. If you would like to use the rules, that's fine, but I always like to write them completely out. So on this first one, we have a 4 with 3 H's and an 8 with a 1H, and that exponent is happening, or that parentheses is happening 2 times because it was squared. Now I notice that I have h's on top and bottom, so I can cancel some of these h's out. Okay, so I have also a 4 times 4 on top, which is 16. And on top, I also have 1, 2, 3, 4 h's left over. And on bottom, I have 8 times 8, which is 64. Now, I also want to see, can I simplify this fraction? 16 divided by 64 in my calculator is 0.25. So if I hit math, enter, enter, I get a 1 over 4, and that h to the 4th is still on top. Now, I don't really need to write this 1 on top because that h to the 4th is there, so I don't need that 1. And there is our answer. Okay, let's look at the next one. I'm going to do D actually next because it's right here. I notice first off that I have this h to the negative 4 that has a negative exponent. So I'm going to move that to the bottom of my fraction. So the 2 is on top, and we have a 6h squared and an h to the positive 4 on bottom, and that whole thing is to the 3rd power. So I'm going to write this all out. We have a 2 with a 6 and 1, 2 h's with 4 more h's on bottom. And that set of parentheses is happening 3 times. I'm going to do my best to fit this all in. Whew, I just fit it in. So on top, we have a 2 times 2 times 2, which is going to give me positive 8. And on bottom, actually, I'm going to give myself a little more room. On bottom, we have a 6 times 6 times 6, which in our calculator would give us 216. And we had, if you count them all up, 18 h's. Now, I want to see if I can simplify this fraction. 8 divided by 216. If I do that in my calculator, I get a 1 over 27. Now, in this one, I need that 1 on top to show that this is a fraction. So I'm going to leave that 1 where it is. Okay, let's try some more examples. Let's look at this B. We have a 7d to the 3rd times a d to the 3rd squared. So we have 7 times 3d's times 3 more d's, and that is happening 2 times. So 7 times 7 would be 49. And if I count up all of my d's, I would get 12. So d to the 12th. There's nothing else I can do, so I am done. Alrighty, on the next one, for E, we have a negative exponent that I see first. So I'm going to fix that. This is divided by 1, and that negative exponent is going to go to the bottom. So we have a 5 with a b squared times 2 on top, divided by a b squared on bottom, and that whole thing is squared. Okay, so I have a 5 times a b times a b times 2, and a b times a b on bottom, and that set of parentheses is happening 2 times. Now I notice I can cancel some b's, so b's cancel, cancel, oh, they all cancel. So I'm just left with a 5 times 2 times 2, which gives me 20. Okay, let's look at C. Okay, first off, I notice I have some negative exponents. that need to go to the top. And I also have something to the 0 power. Now, if it's to the 0 power, that means that it becomes 1. So that bottom is times 1, which really doesn't change our problem. So on top, we have a 5, a g, an r to the 5th, and now we have g to the positive 3 on top. And on bottom, we have an 8 and an r to the 6th, and nothing else. Everything canceled or moved. And that whole set of parentheses is squared. So let's write this all out. We have a 5 with a g, 5 r's, and 3 g's, divided by an 8 with 6 r's on bottom. And that is happening 2 times. So I'm going to write that whole thing again. 2, 3, 4, 5. 1, 2, 3, divide. And 8 with 6 r's on bottom. Okay, so I see that I can start to cancel some of these r's because I have them on top and bottom. So I'm going to cancel. And over here I can cancel as well, leaving me with some r's on bottom and g's on top. So on top, I have 5 times 5, which gives me a positive 25. And I had 1, 2, 3, 4, 5, 6, 7, 8 g's on top. And I had no r's left on top. On bottom, I had 8 times 8, which gives me 64. And I had 1, 2, 3, 4 r's left on bottom. Now, if I type in my calculator, 25 divided by 64, and I try to simplify that fraction, it does not simplify. So this is my solution. All right, in this next example, let's look at what we can do. So first off, I notice that I have 2 different things that have negative exponents. This r has a negative exponent and this t. So the r is going to have to go to the bottom, and the t is going to have to come to the top. I also noticed that I have a g to the 0. G to the 0 equals 1. And if you notice, 10 times 1 is still going to be 10. So that g is basically gone. So let's rewrite what we have. We have a 10 on top, and that t to the positive 4 is now on top. On bottom, we have a 3, a g, and r to the 6th. And now that r to the positive 2 has come down below. So let's write this completely out. We have a 10 with 4 t's on top. We have a 3, a g, 6 r's, 1, 2, 3, 4, 5, 6, and 2 more r's, and that set of parentheses is happening 3 times. 1, 2, 3, 4, 3g with 1, 2, 3, 4, 5, 6, 1, 2, 10 with 1, 2, 3, 4 t's, 3g, and 1, 2, 3, 4, 5, 6, 1, 2 on bottom. That's a lot of stuff to write out. Let's see what we get. We have 10 times 10 times 10, which if we do that in our calculator, we get 1,000. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 t's on top. On bottom, we have 3 times 3 times 3, which gives us 27. And we have 1, 2, 3 g's on bottom. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 r's on bottom. Since we had all different letters on top and bottom, we could not cancel any of them. We can check in our calculator 1,000 divided by 27. If we try to simplify that fraction, it does not simplify in our calculator. So this is our final answer.